morning. Today we are going to see electrostatic potential energy. Okay, that means an electric field is there and we are going to study potential energy for a point charge at some distance. Okay, before that let us see what's meant by a potential energy. Already you studied this in mechanics. Both are similar concept. Therefore, just I want to refresh your knowledge. After that, if you see this topic, then it is very easy to understand. Okay. See, this is the ground level in mechanics. Okay. It is in ground level and an object is kept on the ground. Okay. If you lift the object to some height, say for example h, okay, then your potential energy will be mgh. Your potential energy will be mgh. That means you are doing work against gravity. Gravity is pulling and you are doing against the gravity, because gravitational force is a attracting force. That means you are taking the object against gravity. Therefore, the amount of work done is stored as a potential energy. Okay. For example, if h is 10 meter, then the amount will be certain amount. If you take it to 20 meter here, okay, that means h1 equal to 20, then the potential energy will be more at this point compared to this point. Okay. Now W equal to F into D, that means work done equal to force into displacement or distance, depends upon the your vector or scalar quantity, you can put it. Okay. Potential energy equal to mass into acceleration due to gravity and h. Therefore, mgh is the potential energy. The similar concept we are going to apply here. Here you are taking away from the ground. Okay. That means it is attracting force. Here you are considering one positive charge. Okay. Positive charge means we will be having some external electric field. External electric field, it will have an electric field. That is an electric field. External means not beyond that external electric field. It exerts some electric field. Okay. Now this charge exerts an electric field. Now you are bringing one unit positive charge. Okay. You are bringing one unit positive charge. Let it be A first. Let it be in a position A first. Okay. Now you are moving from A to B. You are moving the positive point charge from A to B. That means this is positive and your test charge is also positive. That means as per Coulomb's law, both are repelling each other. Both will repel. Okay. That means here the object is attracting. Therefore, you are taking away. Okay. Here, therefore, you have to give some amount of work. You have to do some amount of energy. Here it is repelling. While bringing here, okay, against this repulsive force, you have to do certain amount of work. Okay, because against repulsive force you are bringing. Now, from A to B you are bringing. Okay, just like from this position to this position, when you are moving up, potential energy increases. That means you have to do some amount of work from A to B in moving a point charge from A to B. Therefore, the work done W you can write. Now I can erase this. Okay, you can write W equal to, because from here to here you are moving, that means you are doing certain amount of work. Therefore, here the work done will be more. Okay, because you have exerted more amount of energy to bring the object or test point charge from this point to this point. Therefore, your energy at B will be more than energy at A. Okay. Therefore, we can write work done equal to, this is the potential at the point B and this is the potential at the point A. Okay. Now, this can be written as delta U, because work done is stored as a energy. Already you know. Okay. Because in lifting object also you have done some work and it is stored as a potential energy. Here also you are bringing an object or test point charge or test charge from this point to this point. Okay. Therefore, delta U equal to UB minus UA. Okay. Now, we can write in our equation form. Okay. Which equation form you can write? this delta U can be written as you are moving from the object A to B. Therefore, A to B you are writing, and F into dr. Okay, small distance dr you are moving, and you are moving against the repulsive force. Therefore, you are putting minus. Okay, and F here is Coulomb's force. Therefore, you can put minus integral A to B. Instead of F, you can put E into Q dr. Okay, dr means small distance you are moving from A to B. Okay, now here this is delta U. Okay, now delta U is for some charge. Okay, if it is a point charge, okay, or unit charge, then you have to divide this, it is U. Okay, then you have to divide by Q. Therefore, your delta U divided by Q equal to minus integral A to B E into dr. Okay, now this is the potential energy between the point this to this. Okay, now you can write this as VB minus VA. Why VB means potential is measured by the unit volt. Potential is measured by the unit volt. Okay, therefore we are using the letter B. Okay, therefore voltage at B and voltage at A. Voltage at B will be greater than voltage at A, just like your gravitation. You just compare always. Okay, therefore VB minus VA. That means this is the energy. Okay, which is equal to minus integral of, you can write A to B and E dr. Okay, this is important formula. Or you can write this as a delta B also. Okay, because of difference in voltage, which is equal to minus E integral of dr A to B. Okay, this is one important formula. Okay, this one important formula. Now, how you can define this? Okay, the work done in bringing from this to this, we have to define in some unit. Okay, 1 volt. What is 1 volt? 1 volt means if you bring a unit charge, okay, against electrostatic field, and unit charge, if you bring a unit charge against electrostatic field and the work done is equal to 1 joule. Okay, unit charge means 1 coulomb. Okay, the charge is 1 coulomb, work done is 1 joule, then the unit for the, then the voltage is 1 volt. Okay, that is the way of defining this. The work done in bringing a unit positive charge, okay, from some distance, and the energy spent is 1 joule, then the volt is 1 volt, or the voltage difference is 1 volt. Why are you using voltage difference? Voltage difference, what is the need for it? Because when there is a difference, then only we can make use of electricity in application. Just like water is flowing from higher potential to lower potential. Water is flowing from higher potential to lower potential. If river is flowing from higher altitude to lower altitude, then only we can get water at all the places, and irrigation is possible. We can use water as a agriculture purpose. Water for agriculture purpose. If there is no flow, if water is not flowing, okay, without any gradient, then how can we use it? Just like electricity has to flow. For that, we require voltage difference. Therefore, we are focusing the point voltage difference. Now, let us go for a derivation which is very important. Electrostatic potential energy for a point charge. Okay, electrostatic potential energy for point charge. Point charge. Okay, now the same thing, same formula you can apply here. Okay, this is the test charge, not test charge, it's a source charge. Now test charge you can remove. Okay, this is your source charge. That means it gives, it spreads external, electrical field. Now you are bringing one point charge, okay, or unit charge. From unit charge means which one? 1 coulomb. Okay, from here to here. That means what happens? Let it be R, this point, okay, let it be R, and this distance be dr, okay. Or if you bring this, then you can write, or if the point charge is brought from infinity to particular point, then you have to consider only this point and infinity, okay, infinity to particular point P. Okay, in both the way you can derive, but this derivation is very simple. In books also it is followed, therefore I am following this. Now here positive charge is placed here, a unit charge is brought from infinity to this point. Now what will be the potential at this point? That is we are going to do. That means work done equal to, what you can write, integration of infinity to particular distance R, and F into dr, and you are bringing against electrostatic field, therefore it is minus, therefore you can substitute now this for F, therefore which is equal to, here you are bringing for unit charge, okay, therefore integration is infinity to R, you can write for F E into dr, because it is a unit charge, therefore here E into dr W, which is equal, now you substitute for this E value, which is equal to infinity to R, E is Q by 4 pi epsilon 0 dr into 1 by R squared, okay. This is the E value, that means E equal to Q by 4 pi epsilon 0 R squared. Before that we have derived this derivation. Now Q is constant and 4 pi epsilon 0 is there, and the integration of infinity to R. I will erase this. Now what you would do, W equal to Q, you can take outside, 4 pi epsilon 0 minus is there, okay, 1 by R squared dr, 1 by R squared dr. Now you can put the limit also, infinity to R, okay. Now 1 by R squared dr integration is minus 1 by R, okay, minus Q by 4 pi epsilon 0, here minus 1 by R. If you integrate 1 by R squared, you will get minus 1 by R. It is a mathematics formula, okay. Therefore here infinity to R. Now this minus and minus plus, therefore you will get Q by 4 pi epsilon 0 1 by R, okay. Now if you apply the limit, first you go to apply higher this limit, okay, and this one lower limit, higher limit minus lower limit, therefore 1 by infinity, okay. Now this 1 by infinity is 0, therefore you will have Q by 4 pi epsilon 0 1 by R. This is W, and W is stored as a potential energy. Here it is in electricity topic, therefore it is called electrostatic potential. Therefore you can say this as a V, okay. V equal to Q divided by 4 pi epsilon 0 1 by R. Here you have to understand, okay, F electrostatic force, Coulomb's force, is proportional to 1 by R squared, and electric field is proportional to 1 by R squared, okay, and your potential is proportional to 1 by R. This is you have to remember. Here Q1, Q2, two charges will come. Here only one charge will come. Here also only one charge is there, okay. This is important derivation for your examination point of view. Thank you. Please subscribe and please put a comment.